Hello and welcome to Finite Element Analysis and Numerical Modeling using CivilFEM 2019 webinar. You have registered for this webinar through our partner DISTRIBUTOR. My name is Gelu MADEAR and I do represent REVERO Consulting and ECO-ROCCA Engineering, and we are CivilFEM support distributors for DISTRIBUTOR. This webinar is aimed for specialists with engineering background and interested in a professional training in the Finite Element Method, with a focus on civil and structural engineering and also with geotechnical and geomechanical engineering. This webinar is going to provide you a brief understanding of the various capabilities of CivilFEM Powered by Marc for use in finite element analysis and numerical modeling. We are going to touch a little bit of various capabilities of CivilFEM Powered by Marc, inclusive on nonlinear analysis for concrete and steel, geotechnical, geomechanical nonlinear materials, construction state processes with activation and deactivation, multiphysics analysis, and code checking and design. Few things about myself. I am a geotechnical tunneling mining engineer, chartered with the Engineering Council in United Kingdom. I have experience in academia, design and consultancy, and I do have more than 70 publications. My main area of expertise is tunneling, also geotechnical and mining, and I have shown here a few key projects I worked on in my career of more than 30 years. Currently, I'm involved with Lesotho Highlands Water Project, which is an important binational project between Lesotho and South Africa. And previously, I worked on a number of projects in Canada. For example, Johnson project was about 2 shafts sunk using the freezing method, as well as Cigar Lake mine, which is an uranium mine in Canada. Also, I have been involved in a number of tunnels in the UK and around the world. In terms of my expertise, you can contact me and discuss for further details. I am also a member of the Institute of Materials, Mining and Minerals in United Kingdom, where I am a fellow. And also you can see that I'm chartered engineer with the Engineering Council in United Kingdom. About CivilFEM Powered by Marc, this is one of the most powerful softwares available on the market, and this is suitable for all type of civil and structural engineering, geotechnical and construction industry. The software provides a set of tools and unique capabilities that streamline the creation of various models, simulating the construction, then applying loads. We can do also seismic design for mostly all civil engineering structures, doing structural interaction, forensic structural analysis in various fields like energy, oil and gas, power plants, and nuclear. Also, there is a high usage of the software in hydraulic engineering. The software is powered by Marc solver, which is produced by MSC Software, which is part of Hexagon, and Hexagon is a leading global provider of information technology solutions that drive productivity and quality across geospatial and industrial landscape. Marc is a nonlinear finite element analysis solution from MSC Software Company, which is one of the 10 original software companies and global leader in helping product manufacturers to advance their engineering methods with simulation software and services. MSC Software helps companies improve quality, save time, and reduce costs associated with the design and test of manufactured products. If you would like more information about MSC, we can go to their website, see exactly what they are doing. Is mscsoftware.com, and you can find out more details about Marc software. Typical CivilFEM applications would include seismic design, checking and validation, energy power plants, nuclear, wind turbine and thermal, harbor, offshore and naval structures, nonlinear construction processes, structural analysis, and tunnels, mines, slope stability analysis, foundations like retaining walls, piles, surface foundations. Then we have rock and soil mechanic, hydraulic, dams, structures and bridges, cable structures, skyscrapers, sports stadiums, and also we have quality control and procedures in construction work or forensic structural analysis. The software is oriented and used by the following types of companies: in principle civil engineering consultancies, nuclear power plants, research and development institutes, large companies in various fields, petrochemical, energy, construction and shipbuilding, university departments, or small consultancy firms managed by university professors, mining engineering companies, or large international architectural consultancies. To mention, this software is not very useful for small civil projects like residential buildings. In regards with CivilFEM, it is built around Marc Finite Element Method solver, and then we added some capabilities in terms of non-linearities, geometry, and material behavior. And then we have a pre and post processor, and then there is a graphical user interface to be used with the software. If we go to see how CivilFEM is looking. We have the following model. You can see the menu. We have loaded a 3D tunnel, and as we mentioned, we have the pre-processing and the post-processing part around the core element of the software. We define the environment. We have geometry to define. We talk about the model, and then it comes the part related to the meshing, which is part of the MSC software. We apply laws, solve the model, which is again the core of the Marc software, and then we have the results and post-processing with design and check of the various structural elements. If we would like to continue with our presentation, some characteristics of the CivilFEM are the following. It is based on the Marc solver technology. There are various versions of the CivilFEM. We have an introduction version, we have an advanced, an expert version, and also we have a module for the nuclear power plants. There are various licensing capabilities. There is a no float and there is a floating license of the software. In terms of computing, we have the software built on 64 bits processors, and there is a parallel processing embedded into the software. As applications, we have advanced civil engineering for bridges, dams, seismic, reinforced concrete tunnels. We have a friendly, easy-to-use graphical user interface in various languages, and also the software has the capabilities of assuring a quality control process for nuclear power plants. In order to start an analysis, usually we start from this menu in CivilFEM, where we can select from 2D or 3D problem, and there is a capability of doing static analysis or transient analysis, inclusive of modal, harmonic, or buckling analysis. And the thing is that also we can do a structural analysis or a multi-physics analysis. First option of the CivilFEM is CivilFEM Intro. And we have here the details of the capabilities of CivilFEM Intro. We can do a static and transient analysis, a nonlinear transient analysis. We do have seismic tools. We can do a modal and spectral seismic analysis, harmonic analysis, we can do checking and design according to various steel and concrete codes. There is a capability of large diffraction and large strains. There is the option of multi-body contacts with friction and glue using spring dampers, and we can import various graphic geometries, and also we can use scripts and macros with Python. The advanced version of the software will contain the capabilities of the introduction version of the software, and additional we can do a nonlinear buckling, nonlinear evolutive construction process. We can have a nonlinear strain stress behavior, for example plasticity and user crack data. We can do a nonlinear reinforced concrete analysis. We can have time-dependent properties for the concrete. We can have creep behavior and shrinkage of the concrete. We can use material models like Drucker-Prager, Moore-Coulomb, extended chem clay, Hook and Brown, and hyperbolic model. In terms of a CivilFEM expert, we can add multiphysics like heat transfer, either steady state analysis or a transient analysis. We can have a thermal structural integrated analysis, which is a coupled process between structural engineering and thermal engineering. We can do SEEPAGE analysis, steady state or transient for dams, for example, or other water retaining structures. Or we can do a SEEPAGE structural integrated analysis. Future capabilities of the software would include laminated and composite materials, solid-to-shell modeling, and crack propagation. In comparison with other softwares available on the market, CivilFEM has the following capabilities and characteristics. It is an object-oriented programming software for structural element design. You can see that it's able to accept commands using Python language. It is used both for structural engineering and geotechnical engineering, so we can design foundations, soil models, soil structural interaction. Software has a lot of non-linear capabilities. There is an option for multi-body contacts with friction, cohesion. There is the possibility for a non-linear construction process, and it has the capability of multidiscipline finite element method problems, structural heat transfer SEEPAGE, and also has the capability of designing prestressed reinforced concrete. We have discussed about object-oriented programming, so we can define various structural elements and have them written in Python, and then the software will take it from the macro script and then will interpret the code and run the analysis. Another capability of the software is the use of various codes from Eurocodes, Eurocode 2, Eurocode 3, American standards, international codes for concrete, British standards, Chinese, Russian, Brazilian, Indian, Spanish, Australians. So wherever your project is located, you should be able to use the codes already implemented into the software, which will allow you to design or check the various structural elements. In terms of advanced nonlinear capabilities, we have advanced reinforced concrete modeling. We have a number of geotechnical material models. As mentioned, Drucker-Prager, Morkulom, Hook and Brown, Chem Clay, and recently hyperboloid strain behavior based on Duncan Chang model. We have the possibility of changing material properties in time, so it is a time-dependent material properties. We have the possibility to activate, deactivate elements, which will allow us to do construction stages, and that's very useful when we have works in earth or ground, which will simulate the process of excavation and installation of support. There is the possibility to run the software in large displacement mode, and have also advanced contact elements between finite elements. Field structural interaction is modeled, and we have also the capability of using cable elements, inserts, and other stuffs, for example, to model soil nails, rock balls, and cables. As discussed previously, the geotechnical material models are presented here. We have various representations for the stress-strain behavior of the material. It has the Chem Clay model, which is largely used in geotechnical engineering. We have the option to induce an initial stress rate of the model. That's very useful when we have rock masses or ground behavior where we have a certain status of initial stress. And also the last model is the hyperbolic model introduced, which is similar to small strain behavior in similar softwares available on the market. In terms of applications, in regards of the geotechnical capabilities, we have, for example, on this picture, we see the interaction between the foundation of the structure and the soil mass. We see here how the loads are transmitted onto a tunnel, and also we can see how the shear failure will be developed within a slope stability analysis. You have some pictures detailing an initial situation then that was modeled using CivilFEM. Another example of usage of CivilFEM is let's clear the drawings and okay. We can see the possibility of CivilFEM to simulate various construction processes. For example, we would like to do an analysis for a cut and cover tunnel. You can see here the stages of construction, and then we start simulating these stages from an initial mesh which is the basic structure initially using a cut, and then placing our tunnel and applying various strata of compacted soil. We have the capability of simulating the process in time, and you can see here that at different days we had different stresses and displacements within the ground. We can do later an analysis of the structural status within the elements of the tunnel. We have a number of short videos now showing various simulation of interaction between a tunnel and a structure. You can see how displacements are generated through the process of tunneling, and we can monitor how these displacements would affect the building which is above ground. Also, this is the same example. We started with this initially, and you can see also how the displacements are varied due to the tunneling process. On the next slide, we have the equivalent plastic strain which develops within the ground on the same tunneling process, and you see in red an area where the plastic strain is very high, which means that we have a zone where the failure can occur. Again, you see in time how the plastic strains develops and failure can occur. This is another version in another load case. So we see also that the slope has an area where the plastic strain, you see here we have the plastic strain develop and along the cut. So there is a clear possibility that the failure would occur along these surfaces. Also, we have in 2D you can see how the plastic strain would develop in a cross section and how our building will tilt and the zones where the failure would occur. And the next slide, the same cross section and another load case and different material properties, which shows the development of the failure area. Again, another area of application of CivilFEM would be, for example, for wind turbine design, which is in the energy sector, where we have a large turbine which has a foundation. We need to design this foundation and the interaction with the soil mass beneath its foundation. Here in the lower corner you can see the model. What we need to do is to check if the structure is stable. We need to check the concrete for cracking. We need to do a rebar of the reinforced concrete to see the settlements and to see how in general the model behaves. We have the mesh here and you can see the various parts of this model. And we have the wind turbine at the end model and applying the dynamic loads given by the wind. Another area of usage of CivilFEM would be in calculating hydraulic dams, which could be of concrete or loose materials, and as mentioned previously, we can have a SEEPAGE analysis or a structural analysis or an integrated analysis of the dam. For SEEPAGE, we can apply a hydraulic flux on the structure and see which is the pore water pressure and how water would penetrate, would circulate beneath the dam itself or through the dam, and also that would give us an amount of indication of drainage at the two of the dam. We can run a slope stability analysis and also a reservoir drawdown analysis. Drain design downstream to ensure safety. We can have a number of safety factors in in various scenarios, so we can determine exactly which would be the safety factor in various load cases. Reservoir drawdown analysis. You can see when we draw down the reservoir and the equivalent plastic strain, and which develops into the dam itself. In regards with seismic analysis, we would like to emphasize the fact that the software can do various analysis. Sorry, let's see again. So we can define a spectrum. We can have an accelerogram or whatever initial node we have, and then we can do a seismic analysis, either model or using various codes available in internationally for the seismic analysis. We have a response spectrum. We can use the pushover method, and we can do a nonlinear transit analysis. We can have also cycling loads. Few examples of dynamic analysis. We have here a bridge, a steel bridge, where we have a mobile load across the bridge, and we can monitor the vertical displacements in this case. Next bridge is a Tokyo Gate Bridge. Similar analysis, so dynamic. This is subjected to an earthquake, and we can see the deflection of the bridge in an enhanced mode. And here we have another bridge. It's a Masonry Bridge, and is subjected to an earthquake too, and we monitor the cracking strain in this case. There's a lot of cracking strain here at the middle of the bridge, and that was a real case where we modeled the exact situation. We can have also construction stages to model using CivilFEM, and you can see here on the right side we can have a real situation, a cable stayed bridge, and then we can do a similar modeling of the bridge construction. You can see the bridge construction here. You have the 3D tunnel on the lower left side, and also we have the cut and cover tunnel on the right side. Detailed bridge construction. We have the arch bridge construction. You see the stages and the cables, and then the table of the bridge. Again, another example of bridge is a box Girder Bridge. Various construction stages, pillars, and then the tables, and then the final model. The cable-stayed bridge, we have seen this previously. Now it's a single slide. And also the 3D tunnel model in detail. We can see here monitoring the total displacements. We can use CivilFEM also for forensic and structural failure. It's a back analysis system where we have a failure of some structures, and here we have two examples. Hyatt Regency Hotel, where a walkway has collapsed in Kansas City, and a roof collapse at the Charles de Gaulle Airport in Paris. You can see the actual pictures of the structures which have collapsed, and also on the right side the modeling of the phenomenon themselves. For example, in detail you can see how the roof collapsed at the Charles de Gaulle Airport and the details. We monitor here the vertical displacements, y-axis now it's for the vertical displacements. Another application area for CivilFEM is the heat transfer and thermal analysis. We can do steady state and transient analysis. We can do either conduction or convection, and we can specify the conductivity of the material to be isotropic or orthotropic. You can see here various models of heat propagation in various structures. An interesting example would be for the civil engineering in terms of heat transfer and thermal analysis in terms of cracking of the concrete. We know that when pouring large amounts of concrete, a lot of heat is developed due to cement hydration, and then this heat will generate stresses which are on top of the stresses given by the loading of the structure itself. So we can do an analysis to see how pouring in various amounts of concrete would generate stresses which can cause cracking of the concrete. We can do also pre-stress reinforced analysis and design of the structures. There are various options within the software to allow for preloading of the rebars, tendons in beams, shells or solid elements, and make a check in accordance with various codes and standards. We also have an axial force bending moment diagram, which shows us the envelope for the pre-stress reinforced concrete element. It's fast and it allows us to do a thorough design and analysis. We can have various diagrams of interaction. The most advanced option for the CivilFEM is the module dedicated to the nuclear power plants features, and there are several international codes which takes into account this feature, and that is an option which you can select if you do design for nuclear power plants, where the conditions are very strict. There is a quality assurance and quality control procedure, and CivilFEM is able to do such an analysis. These were a few areas of application of the CivilFEM 2019, but if you would like to learn more about in detail how to do various analysis, you can go on our partner YouTube channel and see more webinars on various aspects of design and analysis using CivilFEM, from nonlinear to concrete structures, prestressed concrete, steel structures, forensic engineering, geomaterials, and then coupled analysis like thermal, structural, and SEEPAGE structural analysis. Few things about the companies I represent. REVERO Consulting is a company registered in the UK, and its main area of expertise is geotechnical and environmental engineering, and also some mining activities. If some areas are dealing with contaminated land risk assessment and environmental consulting, some other areas would include geotechnical and complex 3D nonlinear finite element analysis. Also, we provide design services for civil structures placed in various ground conditions, from swelling clays to highly fractured rock masses. The other company I represent is ECO-ROCCA Engineering in Romania, with a little bit different activities, because it emerged as a spin-off from the Mining Institute in Petroșani, with a focus on environment, mining, and geotechnics. Currently, ECO-ROCCA Engineering is heavily involved in some rockfall protection projects in Romania. About our partner, Ingesiber, is a specialized computer-aided engineering, civil and mechanical engineering company. It has more than 30 years supporting and distributing finite element method-based solutions, including consultancy, software development, technical support, and complementary software. Besides the CivilFEM, which is developed around Marc Menta software, Ingestible has a version for CivilFEM for ANSYS, and also has a lot of activities in computational fluid dynamics. Would be interesting to discuss some other time, as CivilFEM is used for ANSYS, for workbench and some other application of CivilFEM, but CivilFEM using Marc is a similar, very powerful software to be used. Ingestible has high expertise in structural civil mechanical engineering as well as computational fluid dynamic projects. Also has an important training program, and you can see here how the activity of Ingestible and also REVERO Consulting and ECO-ROCCA Engineering is organized. So besides software distribution, which is presenting the capabilities of the software to various clients, our companies do consulting work. We also do training and software development, because continuously we have to develop the software through research and development projects. We have a number of case studies which will be subject to a further webinar. I have put here a number of case studies which I would like to discuss with you in a further webinar in detail, starting from geometry, model construction, meshing, boundary conditions, load cases, and so on, and then solving the post-processing, interpretation of the results, design and check of various structural elements. Coming to the CivilFEM prices, obviously there are various options, various schemes, and we can discuss in detail what your needs are. And if you decide to buy CivilFEM, whatever version you would need, please drop us an email today, because we have a special offer for you, and the email is office@revero.co.uk, and please use the promotional code CVF20. Please stay in touch, because we have also the training part for the CivilFEM. In due time, we will launch a CivilFEM course on computational geomechanics for those of you interested in using CivilFEM in geotechnical, geomechanical analysis. This course main objective is to provide the knowledge in using CivilFEM powered by Marc for the civil engineering projects, and people from consulting companies, scientific research institutes, universities can get in touch and have this course. It is based mostly for the tunneling projects, and also would include geotechnical projects and alike. Follow me on LinkedIn, and I will be able to provide you details in the near future. For further details on CivilFEM, please go on our websites, www.revero.co.uk, www.ECO-ROCCA.com, or www.civilfem.com. Thank you for your attention.